FastMCP3's component registration system employs a provider-based architecture, where the local provider serves as the primary storage mechanism for tools, resources, and prompts defined directly on the server. This design pattern enables modular component management through both decorator-based and programmatic registration methods. We're about to examine how a tool object gets instantiated from a function using the toolFromFunction factory method, then registered to the server via the addToolProvider method, alongside similar operations for resources and prompts. The code will demonstrate the direct method approach to component registration, complementing the decorator pattern we've previously explored. From FastMCP Tools import tool. #create a tool object. My tool equals tool. From function sum function, name equals custom tool. #add it to the server. MCP add tool me tool. MCP add resource me resource. MCP add prompt me prompt. This code demonstrates FastMCP3's programmatic component registration pattern, offering an alternative to decorator-based registration. The toolFromFunction factory method creates a tool object from an existing function, allowing runtime component construction rather than compile-time decoration. This approach enables dynamic tool creation, which is particularly useful when tool configuration or behavior needs to be determined at runtime based on application state or external inputs. The pattern shows how components can be added to the server using direct provider methods like addTool, addResource, and addPrompt. This contrasts with the decorator approach shown in the context, providing flexibility in component management. The direct method approach is valuable when components need to be conditionally registered or when working with pre-existing functions that can't be decorated. It also enables component sharing across multiple server instances, as demonstrated in the standalone local provider example. The trade-off here is between convenience and flexibility. Decorators offer cleaner syntax for static configurations, while programmatic registration provides runtime control. This pattern is particularly useful in scenarios requiring dynamic component loading, such as plugin systems or configuration-driven toolsets. The code maintains FastMCP's provider architecture, where all components ultimately reside in the server's local provider, ensuring consistent behavior regardless of registration method. Let's break it down. From FastMCP Tools import tool. Imports the tool class from the FastMCP Tools module, making it available for creating tool instances in the current scope. #create a tool object. My tool equals tool. From function sum function, name equals custom tool. Creates a tool object named myTool by calling the FromFunction class method on the tool class, passing some function as the function to wrap and setting the tool's name to custom tool. This instantiates a tool instance that encapsulates the provided function with the specified identifier. #add it to the server. MCP add tool me tool. Registers the previously defined myTool with the FastMCP3 server instance, MCP, by invoking the addTool method. This makes the tool available for use within the FastMCP environment, though the specific functionality of myTool isn't visible in this line. The operation is synchronous and completes when the method returns. MCP add resource me resource. Adds the resource referenced by myResource to the FastMCP3 instance, MCP, making it available for subsequent operations within the framework. MCP add prompt me prompt. Calls the add prompt method on the MCP object, passing myPrompt as the argument. This registers or adds the prompt contained in myPrompt to the FastMCP3 system for processing. FastMCP3's provider architecture enables flexible component registration through both decorator and programmatic patterns. The code demonstrates the direct method approach, where tool from function dynamically wraps an existing function into a tool object at runtime, contrasting with compile-time decorator registration. This pattern shines when components need runtime configuration or conditional loading, such as in plugin systems. The add tool, add resource, and add prompt methods all funnel components into the server's local provider, maintaining consistency regardless of registration approach. The trade-off is clear. Decorators offer cleaner syntax for static setups, while programmatic registration provides runtime control. Both paths converge on the same provider-based storage, ensuring uniform behavior across the system. This dual approach gives developers the right tool for the job, whether they need simplicity or dynamic flexibility.
The middleware births the tool in silence. Yet the name that finds it unravels its very thread.